Good evening, or good afternoon, or good morning, wherever you're joining us across the world to Data Science Nigeria AI Everyday Virtual Bootcamp, which is 5 days of extensive immersion into best practice learning, focus on industry use cases, and even postdoctoral research, examples, business models, application to support our development during this period of lockdown. I know a lot of us who want to sustain our learning, and that is why at Data Science Nigeria, we have created this platform to continue to engage our community, both in the industry and on campuses, to ensure that we're in the cutting edge of knowledge. So you are welcome. So from today till Friday, we're going to be running these daily classes between 5 and 7 p.m. Nigerian time. Nigerian time is GMT +1. And we are privileged to have today is the first of the days. And our first speaker today is a very respected expert who is so passionate about the community. That's Dr. Isi Idemudia. She's currently working with Accenture in the United States of America, but specifically Atlanta. She'll be talking to us about how to use AWS Sagemaker for data science. AWS Sagemaker is a simple, exciting drag and drop, which will be very useful to many of us who are working in the industry, who are looking for immediate, ready-to-use, self-service, step-by-step learning tool. And this is going to give us some licenses to be able to practice. On Tuesday, we're going to have Dr. Kingsley Okoye, a data architect based in Mexico. He will be leading us through data science in action, through process mining. The class will help us to build capacity in problem solving, for business leaders, students, and researchers. Wednesday is going to be around postgraduate research in data science and machine learning. And we have a very proud student of our community, Idris, who is currently doing his PhD at Iowa State University in US. So we'll be talking about life of a postgraduate data science researcher. This is a very practical class, what to watch out for, how to study, how to research. I believe those principles are still very applicable to any one of us, so don't miss that. On Thursday is all about industry use cases with Dr. Isi of Fujitsu United Kingdom. You'll be looking at best practices to problem solving with data science. We've learned over time that it's not just about coding, it's not just about drag and drop. It's about first understanding what the problem is, what data do I have, how do I scope, how do I define the problem, how do I apply my data, how do I solve real problems that add value to business. So these are things I'll be talking about. On Friday, we have John, a data engineer with Daimler AG in Germany. He will be talking to us about Microsoft Azure. Microsoft are a very special partner to Data Science Nigeria. And we promote Azure specifically within our business environment and also for the academic environment. So he'll be talking to us about the certification path, how easy it is, and he will be doing some introduction to Microsoft Azure, particularly the machine learning space, to stimulate many of us to explore this path. Okay, so 5 days of learning, AI Everyday Virtual Bootcamp. Just to talk about ourselves again, we're Data Science Nigeria. We have vision to raise 1 million AI talent in 10 years. Of course, you can be part of this vision as we focus on research, on business application, AI startups, and drive employability, and a lot of AI for social good. We run a lot of free classes across the country, on campuses, in communities, at our hub. We are humble to say we run the biggest learning platform on the continent in terms of scale, and in terms of outreach and consistency, and the fact that we also offer this both online, off the line, face-to-face, and project-based learning, and also for all segments across various learning levels, beginners, intermediate, young people, old, professional, at different level. We also run paid professional training, which is very important. So this website should be a website you visit every day to look at all our trainings. These are our paid training. Basically, our paid training allows us to support professionals in the industry on best practices, on building industry-ready skill. And of course, the way it works, this kind of training support our ability to fund our nonprofit by offering more free trainings for young people across the country. These are examples of companies that we have trained. We have very robust training program that can be customized to an industry, specific to a category or a business, or perhaps accelerate the development of an individual. We do a lot of executive level learning programs for all all levels of executive, middle level, decision maker, and even board level. We facilitated strategy session at board level on understanding digital transformation using AI and data, and how the organization can align itself for incremental revenue, cost reduction, and efficiency. So Data Science Nigeria can help organization to articulate its data science and AI strategy. Okay, so once again, these are paid training link. Please take the picture, visit the page, and see all the training that we have available to you. In addition to that, we also offer a service called Data Science Recruitment, where we help organizations to recruit high-quality data scientists, machine learning experts, using our unique hands-on validation, project-based interviews, and onboarding processes. Like this advert says, when you recruit only through CVs and resume, you might be shocked that you've just been buzzed by buzzwords. What you see in CV is not what is in reality. So we know how to filter through all the buzzwords. This is what our guys do every day. We have a consulting unit within our organization that is solving business problems for leading organizations in Nigeria and for development agencies. So this is what we do every day. So we're able to know who is who has got the right skill set that can help your business. So it takes an expert to differentiate between fake and original. So engaging Data Science Nigeria will help you to recruit quality people. And we can filter out all the claims on CV and get you people who have got real skill that can be onboarded immediately and deliver return on investment to your business. Okay, just call 0814 00000853 or email Oluwaseun at datasciencenigeria.ai and enjoy this bespoke service. So beware of artificial intelligence and data science scammers. What you expect is not what is in reality. Get us to help you recruit high quality talent. And this is our process for doing that. Very robust, very detailed, very methodical, hands-on. And by the time we're done, we hand you over the expert, and then you can take them through the normal background check, alignment, personality fit, and then get them to start the job immediately. And then if you have projects, you've got all kinds of data, in numbers, in text, in sound, in pictures, in video, in geospatial. We offer bespoke consulting support and data analytics on-demand services to exceed your growth ambitions. So we make sense of all kinds of data. So Data Science Nigeria offer robust consulting service. And I'm humbled to say we're working for multinationals, global, reputable development agency who have trusted us with the quality of outcome. And why? Data Science Nigeria, number one, we are an award-winning community or world-class expert, having won a leading African award, both in research and in community building. And more importantly, whatever is made from our training or from our consulting is invested back in training more AI talent free of charge, execute research projects in different areas, and expand our innovation frontiers for social good, so that we can achieve our vision to raise 1 million AI talents in 10 years. Those are the reasons why you need to patronize Data Science Nigeria, training, recruitment, consulting, solution delivery, data collection services. So these are past training that we've done, very successful. You want to know more about us, download our annual report. because we are a registered charity, audited, governed, and managed for excellence with a reputable advisory board. So this is about us. Follow us on all social media, our website, Twitter, Instagram, Facebook, YouTube. YouTube has a lot of our past learning videos, one of which is 100 Days of Machine Learning. So many other classes from our bootcamp, they're all there. Learn, grow, maximize this period of lockdown, get yourself into best form for what is ahead. So back to why we are here today. 5 days of learning AI Everyday Virtual Bootcamp. Let's go straight to class. It's a great privilege this evening to have Dr. Isi Idemudia of Accenture, United States of America, to kick off AI Everyday Virtual Bootcamp starting today. She's going to be leading us on how to use AWS Sagemaker for data science and machine learning. Like I said, simple and exciting drag and drop that you can use to solve machine learning problem in the industry. She will tell us how she's going to give us a free license so that we can practice as she's teaching us. So let me talk a little about Dr. Isi Idemudia, someone who is very passionate about giving back, somebody who is genuinely keen about building capacity and giving back to society. She just wrote a book that's going to come out in a few days, Out of Africa into the Cloud. Girls Can Code Too. So watch out for the book, and I'm sure she will also speak about the book. So Isi was born and raised in Port Harcourt, Nigeria. She schooled in Nigeria. She relocated about 7 years ago to United States. She's very passionate, genuinely passionate about giving back. Don't be surprised that Isi will make it to our AI boot camp in October. So that's why you need to start getting ready to be among the 250 best of the best that will make it to our boot camp. Isi is very passionate about giving back through our involvement in Girls Can Code, Girls Code, and Kids Can Code, both in Nigeria and USA. She's AWS Cloud Solution Associate Manager at Accenture. It's a great day to learn. It's a great week to learn. Have fun, learn. Let's welcome Dr. Isi Idemudia to the first class today.
Hi, good evening. I'm so excited to be with all of you today. I hope you've had a good time staying at home and everybody's being safe. Okay, yes, that's important. We need to stay safe, wash our hands, keep us around us clean, and be home. Okay, my name is Dr. Isi Idemudia, and I'm excited to share with you this evening. We've been here in the US, we've been at home like 3 weeks, and everyone is just using the opportunity to learn, to dig deep into a lot of resources. All of those links that you saved. I'll get to it. You never get the chance to. Now is the opportunity to go through all of that and really come out of this situation a better person. So I'm gonna share my screen real quick. Yes. So today we're going to be looking at machine learning, but from a different perspective, and that's from the perspective of the cloud. We're going to be specifically looking at Amazon Web Service Cloud today. There's something called the Cloud Wars, and there's this contest who is a better cloud provider. The top 4 cloud providers are Amazon Web Service, Microsoft Azure, Google Cloud, and Alibaba Cloud. Okay, I've mentioned it in the order, I think. So just a little bit about my background. Currently an AWS Cloud Solutions Associate Manager at Accenture. I work out of the Atlanta office, but as a consultant, I get to travel all over to work at a client site. Before that, I was a managing partner. I ran my own consulting firm here in Atlanta. And then while I was in Nigeria, I worked at an IT firm called Venture Garden Group. I headed the government relations team. And then I have a bachelor's degree in computer engineering from River State University of Science and Technology in River State, Port Harcourt. Then I went ahead to do my master's in information technology at Vladimir University of Technology, Lautech, in Osun State, Nigeria. I did my PhD from University of Port Harcourt, the Institute of Innovation and Technology Management. I am currently doing my second master's in enterprise AI at Northeastern University in Boston here in the US. I just rounded up a program on applied machine learning and data science at Emory University in Atlanta, Georgia. So that's just brief about me. So why are we here today, and why is it so important for us to take our time to look into AI machine learning? Because the fundamental challenge is that there's 1,000% growth in data every 2 years. And this was even statistics before the epidemic. The epidemic, because people are now working from home, there's a huge amount of data that will be as an offshoot of this crisis. So we're going to see this number really grow high exponentially. There's the world population is growing at an alarming rate of 2.2% in the past 2 years. So there's so much data and there's a lot of people. Because of that, there's data that is untapped, and people and the customers can hire fast, in order to keep track of the data that is coming out. So we need machines who can help process all of this data coming out. So why machine learning? Machine learning is just a technology that enables computers to learn human expertise. So the experts are really humans. So let's not get afraid here. The experts are humans. We are just teaching machines how to learn our expertise. And that's because we as humans, sometimes we get tired, we need to rest, we need to take a break, we need to go on vacation, we need to take care of our husbands, we need to take care of our children, we need to go hang out, we need to go to church, whatever. It's just a lot. So we could actually step back, live our lives, and teach machines to do the things, those rudimentary things that we would normally do. And machines can actually scale our expertise faster. And then we as humans can use our brains to begin to think of more creative and innovative solutions. So, like I said, we'll be looking at the AWS machine learning stack. And AWS has the AI services. There's quite a lot of them. Amazon Comprehend, Amazon Lex. Amazon Lex is actually used to build your chatbots for customer service. Amazon Poly, Amazon Recognition is the facial recognition solution of AWS that recognizes faces based on patterns. Then we have Amazon Translate, Transcribe. Translate just literally translates from one language to another. You put in your text and does translation. Amazon Transcribe and Amazon Personalize. I love Personalize particularly because this is the algorithm that Amazon uses to make recommendations. When you go to Amazon.com and you shop, they make recommendations, and shoppers will bought this, also like this, and those are the recommendations that I make. So they've taken the solution that they're using themselves, to give to the public, which I think is great. They also have a bunch of machine learning services, which we're going to be focusing on today. And their machine learning services are all wrapped around one big service called Amazon Sagemaker. So we'll be taking a deep dive into Sagemaker today. We will do the theory, and then we'll go into the demo practical, where you'll be following us along with me. Also all the underlying machine learning frameworks that you're aware of, or you're used to, Keras, TensorFlow, MXNet, all of those environments are also available in SageMaker. So you don't need to be worried. There are certain issues with machine learning the way we know of it, or as we do it today. We fetch the data and then we try to clean it up. We check if there are null values. We check if there are duplicate values. We check if the data is undersampled or oversampled. That we do the transformation. We try to make it scale, linear enough. We do, Then when we think that the data is good enough, then we now start building the models, and we do different trial and error. We try to get the best model, and then we go through different parameter optimization. We try to optimize the hyperparameters to find out which is best, which gives the best accuracy, and then we go through that process over and over again before we finally arrive at the model which we want to take to production. So it's quite tedious and hard. That's the current problem. So what AWS has done is to try to simplify that process while giving you the best output. So with AWS SageMaker, you're able to build your model, train your model, and deploy machine learning models quickly at scale. So the SageMaker Studio is where we're going to be focusing on today. It was released at the Amazon reInvent in December. Studio is a full suite. We have the collaborative notebooks, those are your typical Jupyter notebooks. You could do distributed training of your data sets. It does the tuning and optimization for you. It does experiments. So when you load in the data, it creates different trials for you to identify what model would give the best output for your data set. You don't have to do anything. What you need to do is specify the data set and identify what your target variable is. And SageMaker Studio, the Autopilot, is able to run the entire pre-processing, feature engineering, and then builds the model for you. So this is what the Amazon SageMaker Studio looks like. It looks pretty interesting. Yeah, so I was saying this is what the Amazon SageMaker Studio looks like. On this end, right here, you can see some analytics, monitoring your production, how your model is doing in production. You can also see how to debug your deployment. When you're training your model, you can see have access to the logs, and then if there are any issues, if the training wasn't successful, you could go and see the logs and debug what the problem was. And then right here, you can see these are the different experiments that were created. When you load your data, it will create several experiments with different kinds of models, machine learning models, and then run all of them, tune the parameters for you, and then come up with an optimal set of parameters and model for you. So that's what is going on the left. we're going to see during the demo what it really looks like. It's pretty interesting. So the different components of the SageMaker Studio, which we're going to be really focusing on today, we have the SageMaker Model Monitor. The monitor is used to monitor and analyze your model in production. So once you build a model and you're using it in production to actually see how your model is performing in the real world. So the SageMaker Debugger, this helps you throughout when you're training your model. It does an inspection of that training process, and it helps you to analyze and debug the data to detect any anomaly in case your training process didn't go through well. You could debug using the SageMaker Debugger. We also have the SageMaker Experiments, like I mentioned. It provides iterations, just trials of different sets of hyperparameters, different set of infrastructure, and different models. And it gives you mixed suggestions, recommendation of the top set of parameters and model. Then we have the Autopilot. The Autopilot is like the engine. The Autopilot provides automatic machine learning for users who don't know anything. There's some of you here, on this session, you have no knowledge or little knowledge about machine learning. You really, the speed at which machine learning is growing, you may not need to spend so much time understanding the statistics behind the different models. Except you're just super interested in it. Right now, the future of machine learning is being able to apply these models to real world situations, to solve social challenges and things like that. So the Autopilot does all the machine learning for you. It builds classification and regression model. All you need to do is to provide your data sets in the tabular form, specify the target variable, and it will build a model for you and deploy for you. Isn't that cool? Yeah, I love it. We're going to see that in action very soon. So the SageMaker Autopilot, like I said, you specify a prediction target. And once you do that, you would create regression models and classification models for you. You would do your feature engineering. So what features are noise? You identify what features are not needed in the model, or what features are highly correlated, because we don't want our independent variables to be highly correlated. It would take those variables out. You will identify where you have null values, and find the best method in replacing those null values. You're guys going to use the mean, or it will do all of that feature engineering for you. You would do automated algorithms. So you will select the best algorithms for you, 2, 3, 4, 5, 6, up to 7 different algorithms. And then you would deploy the model. It will provide you a commented notebook describing all the actions that are going to be taken. So all the actions from cleaning, feature engineering, the models that it's choosing, the different hyperparameters, different infrastructure, capacities. It will create a notebook for you, a Jupyter notebook that you can actually take into any environment in the Jupyter lab and run it. And it will run. You can see all of the steps and actions that it took to arrive at a solution. And it's obviously integrated with the studio. So how does this really work? This is the we're talking about the autopilot. It would do candidate generation. So it will analyze your data set. Like we said, it will calculate all the statistics for you. It will determine the best combination of instance type. That's what kind of servers she'll run this model you're building to do all the pre-processing for you. So the feature engineering, what features to remove, what features to augment, and then it will build the algorithm for you, different algorithms. You will evaluate all of those different algorithms, and it will kind of score the algorithms based on performance, and then you can choose what different algorithm or what trial you want, and then you can deploy it. So you'll prepare that candidate notebook for you as well. And the notebook has describing the different choices. So what was the thought process behind the model it shows? If it was logistic regression, if it was a linear learner, if you did a k-means, if you did clustering, what kind of clustering it did, it would give you full description about it. Then you'll be able to see it to do up to 7 different models for you in parallel. They'll run 7 different models, and then for each of those models, it will tune the hyperparameters, and then also tune the pre-processing, so in terms of the feature engineering, if, how the nulls were replaced, if duplicate values were taken out, it would give you the best combination of pre-processing, the choice of algorithm, and your hyperparameters. And you will be able to see all of that in the documentation. So the SageMaker debugger, how does it work? It takes in when you upload your data and the model is being trained, all of that information it writes it into an S3 bucket. From S3 bucket, it pushes out the logs and all of those events into Amazon CloudWatch events. So you could actually go to CloudWatch. CloudWatch is like the central monitoring and login platform on Amazon Web Service. So you could go and see line by line, second by second, all of the activities that are done in the training process. And then you could see, so if something goes wrong, you could go line by line and see what happened, where it went wrong, and what the issue was. So you could take corrective actions. And it's real time. So the Amazon SageMaker Model Monitor, this is what it looks like. You can see how your model is performing over time, in real time. So you could look at the performance and see how to improve that performance. So this is what our SageMaker Studio looks like. Once we dive into the demo, we're going to see right here, you can upload your existing Jupyter notebook. If you have a notebook or a model you've created, sometimes I like to do that. I solve a problem myself, and then I upload it to SageMaker Studio, and then I allow SageMaker Studio also run exactly the same problem, and it gives me several solutions, and I try to check what the accuracy, compare the accuracy between both, and kind of try to also see the methodology in which SageMaker used compared to my thought process. Right here, this is where we create experiment, and we'll look into this during the demo. So I'm gonna go straight into it. So this is what your Amazon Web Service console looks like. At this point, we should all, I've shared the accounts with the organizers, with Bio and the rest and the team. and I've created a username and password for you. If you have your own AWS account, feel free to use it. It's just that this exercise is going to cost you about $16, but you could use environment for it. And then, so this is the console. You sign into the console. You would, in your case, you would click and it takes you straight to the IAM user, but you put in the password, username and password, and then you log into the console. So this is what the Amazon Web Service console looks like. We're going to start with S3 bucket. The S3 bucket is just a file storage system on AWS where we store files. Pretty much the same way on your Microsoft Word, on your Windows or Mac, you create a folder and you throw stuff in it. You put files, or you can create a subfolder, a subdirectory. That's what S3 bucket is. So what we want to do from this find services, we'll search for S3. And then right here, we're going to create a bucket. So you guys should be following along with me. So I'm going to take it slow. So you create a bucket right here. And you give a bucket a name. Now, this bucket name has to be a unique name across the globe. We all cannot use the same name. So I'm going to do DSN class. It cannot be capital letters, sorry. DSN class. You see, you could give it whatever name you want. So the Amazon Sagemaker Studio is only available in Ohio region. So when you come to region, you need to change the region to US East 2, Ohio. Amazon just has different like data centers or data farms where they manage all of your resources from. And certain services are only available in certain regions. So if we use US East 2, and then we don't want to make this folder public. That's why I checked here, and then create a bucket. So it's successfully created a bucket, TSN class Isi. It's in the Ohio region. It's not public, and this is the timestamp when it's created. So inside the bucket, I click on the bucket name. It takes me straight into the bucket, and you can see the bucket is empty. This bucket is empty. Upload new objects to get started. So I'm going to upload this bank. No, we're not doing bank. We're doing the COVID-19. So I want to upload the COVID-19 data sets. I've shared it with Bio and the team. So I have it right here. Put in the train CSV. You know what? I think I'll just upload all of the. Okay, no, let's take it one step. So this is the S3 bucket. This is the file we've uploaded into this bucket. We need to keep note of the path. So we could copy this part right here. Okay, so we have our S3 bucket, and we have uploaded our file into the bucket. The next thing we need as a prerequisite is we need to create a role. A role is just what gives you permission to what you want to give the machine learning model or permissions to be able to access S3 buckets. So let's create a role real quick. From here, we'll go to IAM. This is the Identity and Access Manager. We'll go to roles. So from roles, we want to create a new role. Create a role. AWS service. So there's two services. We want to look for SageMaker. Right here on the far right. So we'll click on SageMaker. We'll click next. We want to give full access. Yeah, so that just shows you detail about the full access, but so we're attaching this policy to it. We'll say next. We'll say next. And then we'll give this role a name. Call it SageMaker execution role. Because we're all using the same account, you don't have to create this role. Everyone will have access to it. SageMaker execution role. Okay, I'm gonna create this role. This is a SageMaker execution role. Another thing that we need to attach, I'm gonna attach another. We need to be able to access S3 bucket. So I'm giving S3 full access. Attach policy. And you could see that this role that we created, SageMaker execution role, has two policies, S3 access and SageMaker full access. Okay, you don't have to do this. But you could do it on your own during your practice time. So if we go back to the deck, prerequisites, we need an AWS account, which I've provided. We need an S3 bucket, which we created just now in the demo. And we uploaded the file, the COVID-19 file, a CSV file. And the data in the CSV file has to be in the tabular format. And then we've created a SageMaker role. So these are our prerequisites to start the demo. Okay, so at this point, in the search bar, we would search for SageMaker. No, don't allow your laptop make crazy suggestions. Yes, so if you haven't done anything, you get this page for the first time. This is the Amazon SageMaker Studio. And we're going to go right to the studio. Yes. And then quick to get started. We'll just give a username. So we could leave the default username. And here you can see it's asking for the execution role. So I'm going to, at this point, look for the role that was created. We just created the Sagemaker execution role. So we give that role to it and we'll say submit. So you are going to have to go through this step. You could change, instead of using default, you could put your name in front of it. And we are creating an environment, our own studio environment, where we could build our models, train, do pre-processing, and everything in that environment. It takes a few seconds to. We could see it's preparing your Amazon Sagemaker Studio, it's configuring the resources you need. It's a one-time config, and it typically takes a few minutes. So we're going to wait for this to get up and running. And I'm going to show you what it typically looks like. Yeah, I'm going to have to log in using my MFA, so give me a second. So this is another account where I kind of have it running. So I'm going to show you what it looks like. Let me know in the chat if your environment is set up. And if you're having any trouble, just ping me. So that's an environment I already had. The one I'm creating now is still deploying or still creating the environment. It's just taking a minute to set up. You can see it's available in preview. It just means that some features may be added or if some features will be taken away in the future, but Amazon is still continuously improving it. So this is loading. If you have any questions so far, let me know. So what we did is that we went to S3. We created a bucket. The bucket name has to be unique, and it should be in the Ohio region. You can give it your own name. If you use a name that already exists in the world globally, it has to be a unique name globally. If the name already exists, it will let you know that name already exists, so you choose another name. I just try to just change it. If you put your name, your own personal name beside it, but well, if your name is not unique, too bad. We don't have a lot of people very easy, but I'm sure you figure it out. Just try a couple of names until it accepts the name that you provide. So we created a bucket and then we uploaded the COVID-19 CSV file into that bucket. Then I created an execution role, and that execution role had two permissions to access S3 bucket, and the second permission was the Sagemaker full admin permission. So these are the two permissions that the role needs to have, and then we're going to wait for this to load. So this is the one we just created, the Sagemaker Studio. So if you have yours created, good luck. I should be able to see everyone's. So open Studio. Okay, so this is what I was showing you. This is what your Amazon SageMaker Studio looks like. This is it's an experiment. These are the list of experiments that I've worked with in the past. So I'm gonna be looking at this is the COVID-19 data set. Well, I'm going to show you how to set the experiment up and running. Okay, so this is still loading. Let's just give it a few. Oh, this is loading. Yeah, so this is Jupyter Lab. It's just Amazon's own way. So if you are at this point, kudos, good job. We have our Amazon SageMaker Studio all set up with the right permissions. We have our S3 bucket, and we have uploaded our CSV file, that's our data set, into that bucket. Now, what we're going to do, we're going to click on this hourglass. It looks like an experiment, when we're taking WIAC. Chemistry lab, yeah. So this is an experiment. And then you're going to click on Create Experiment. And here you're just going to give it a unique name, okay? I'll call it Data Science Nigeria class. And then right here is the S3 bucket, the path to the S3 bucket. So we could go back to the S3 bucket. It's your history usually shows you the most recent services that you set for, because AWS has a whole lot of services, as you can see. So a few ways of finding what your SageMaker is. If you've accessed it recently, you'll see it on the left-hand corner, or you can typically search for it here on the search bar. No, but we want to go to S3, not SageMaker. So go back to services and then S3. We want to get the location and the path to this is the buckets that we created. We want to get the path to the data set. And this is the train. The CSV will click on the tick here. And then once we click on the tick, we would copy the path. Once we copy the path, we'll come back to our Jupyter Lab. Remember, we went to experiment. We said create experiment, and it gave us this environment. We gave the experiment a name. It can be anything, any name. Okay. But you can see it can include hyphen, but no spaces. So now we need to put the path, the S3 path, where the data is. And I'll put it here. And then what's the target attributes? So if we look at the data set, let's see if I can find it real quick. This is what our data set looks like. And in this case, we wanna predict the fatalities. This is the country, date. This is still, is it February? Okay, we have a few match. I want to see if we can predict number of fatalities based on either the country or based on the month to predict what number of fatalities the country will have. So our Y variable is our target variable, will be fatalities. So I copy fatalities and come back here. We put in our location where the input data is. That's the CSV file and the S3 bucket. Now, what is the target attribute name? It's fatalities. Where do we want our output data to be? So typically, I put it in the same location. I call it output. So we'll just change the last, take out the CSV here, this string.csv, take that out, and then create. This automatically creates another directory or subfolder called output, where all the model data will be, the pre-processed data will be stored in the output, and all your model artifacts will be stored in this output. And then what kind of machine learning problem type? So we just want to leave it auto. If you're super sure you want to do a binary classification or linear regression or multi-class classification, then you can specify. But if you want Autopilot to do its thing, then you leave it at auto. Do you want to run a complete experiment? We'll say yes. And then we'll create an experiment. And you can see there's 4 bars we have right here. It will analyze the data, complete analysis, how many rows, what the shape is, if there are any nulls, what's the data type for each of the columns. It will do a describe, it will do an info, all of those things that we typically do manually, it will do under the analysis. And then once it's finished, it will go into feature engineering, where it now begins to trim the data and make it ready. This is where all the pre-processing takes place during the feature engineering phase. Once it's done, it will now go to model tuning. So it will build a model and then begin to tune using different hyperparameter tuning. Then it will get completed, of course. So this is going to take a while to run, and it should be running on your end. So I'm going to jump real quick to exactly the same data set so that we can see. So don't interrupt this page, just let it run. I mean, you can move around to right here. You can see, like, if you want a new Python notebook, you could create one right here. And yeah, Markdown, text file, terminal. If you have a notebook that you want to upload, you can upload your notebook from here. You can upload files. You want to create a new folder, you can do that from here. But this is our experiment just taking place. We just, this is what it's going to look like once it's created. So what is what you're going to see here is that you can see validation. You use the mean square error. This is the mean square error, minimum mean square error, and the final value of mean square error that was used for this tuning job. So it breaks those trials into jobs. And this DPP is pre-processing. This is the pre-processing that was done. So you can click on it and see how pre-processing what was done at each stage. You see metrics, you see the parameters that were used. But I want to be able to, okay, I didn't set up debugger. What I want to show you so we just pause and just wait for our panel to keep running. If you've not gotten an error by this time, you should be fine. Okay, so hopefully by now you can see that the analyzed data field is completed. It now has a green and a tick. This other one still shows the time sign, meaning that it's now doing the feature engineering, then it will get onto model tuning and completed. But what this first phase has done for you is the magic. What it has done is you can, on the top right corner, you're going to see 2 notebooks, which has been saved for you in your output folder in the S3 bucket, which you can open. Click right here. It's going to open that and the data exploration. So if we look at the data exploration right here, Amazon Sagemaker Autopilot data exploration, what it's doing for you is to understand how the job analyze features, to select in the pipeline, that's for the model, what features to use, and how it has modified and improved the pipelines using the knowledge you provided. Any section in blue are sections where you could go and if you want to improve or make changes to it. This is a Jupyter notebook. You can take it anywhere. You can take it to your PyCharm, whatever environment you're happy with. So here it's saying suggested action items. You need to verify that this input header. So this is exactly the data that was sent on the CSV. It's just saying you should confirm that this is right, confirm these headers, and yes, this is what was uploaded. It's doing a column analysis. Now look at this, doing the percentage of missing values. So where you have none or white spaces or any empty field, it would do all of that for you and look at percentage of missing values. For province states, there's 57% missing values, and country region, there's 0.34% missing values. These are things that if you have to run the code yourself, you would, yeah, you know what I mean. Right here, number of unique entries and number of words. This is doing some descriptive statistics. It's comparing the confirmed cases and fatalities. Look at the mean, median, minimum, and maximum. And this is the Autopilot candidate definition notebook. Now it has detected data set has 6 columns, and the fatality is used as a target column. And it's being treated, it is identified by itself, it's a regression problem. And so this Autopilot will build a regression module that minimizes the mean square error of the trained model. You can see that the input data has been randomly split into 2 pieces. One will be used for training, and the other will be used for validation. Now, this is your notebook that you could use anywhere, on any platform, any environment. And so you can see it did some data transformation strategy. It converted the missing values to none. Converted category graph features using threshold 1 hot encoding. And then it does a standard scaler to be used to tune the XGBoost model. And here is what it's done. All of this is data transformation strategy. This is data pre-processing 4 using linear learner. Data processing 3 using XGBoost. Data processing 2 using XGBoost, but this is using different pre-processing or feature engineering methods. This is a linear learner. It's using a combined robust computer and robust missing indicator. And then it's applying also a quantile extreme value transformer. So it's running several data pre-processing, DPPs, data pre-processing. It's doing all of this for you. And then let's look at the candidate. It's using a multi-algo hyperparameter tuning. So it's going to use multiple algorithms for you. This was the data exploration. And then this is the candidate notebook. Different pre-processing methods that are being used. But I'll show you where it tells us how many models are being used. Right, so you see generated, where you have generated candidates. Sagemaker Autopilot has analyzed the data set and has generated 10 machine learning pipelines. So you have 10 different models that are running as we speak. And it uses these are not 10 models. These are 10 different sets of parameters. So hyperparameters, the pre-processing methods, and the underlying AWS infrastructure. He has selected the best 10 scenarios and is running those 10 scenarios along with 2 algorithms. It has identified that this is a logistic regression problem. You didn't have to tell it. You just specified your Y variable and your data into your S3. So, and it's using 2 algorithms. Each pipeline contains a set of feature transformers and an algorithm. So these 10 pipelines is created. It has either of those 2 algorithms and then different set of pre-processing, feature transformation to give you, it will run the 10 of them as trials. This is where we have talked about experiments. It will run all this 10 different these pipelines, 10 machine learning pipelines. They are the different trials that were run. And it would now give us the results of all of this trials and experiments based on the accuracy. So this is the first candidate. It will transform your numeric feature. So it converts your missing values to none, your categorical features. It will do 1 hot encoding. So it will give each of those categories 1 or 0. That's 1 hot encoding. And then it will do a standard scaler. That's the first one. Data pre-processing 2. Now let's see how so if we go to trials, you can see, if you look on your left, you're going to see all the tuning jobs. It's running each of these tuning jobs. You can see the instance type where we talked about the different infrastructure. It's using an MM5. This is the size of the disk. That's the EBS volume size. The gamma size, lambda, maximum depth, these are all hyperparameters. You didn't set anything. It gives you the optimal parameter tuning. Your artifacts, this is the inputs, the train data. It split the data into 2 to keep someone's validation, and your output is stored here. So you can always go there to look for, this is your S3 bucket. You could go to your S3 bucket to go and pick the file later on if you want to look at it. So it's still, if you count the different charts we have here, there's 10 charts because there's 10 different pipelines it's running for you. So I know that our job is still running. Let's check where we are at. Good. So we're done with feature engineering now. We analyze the data. We'll have a tick on feature engineering. So it's completed that. Now it's now tuning the different model. So if we go here to the hourglass and we go to our experiment, right click, open and trial, you will see everything that is ongoing. Some training jobs are completed, some are in progress, and as it's running it, it's putting at the top the most accurate tuning job. So as the accuracy comes out, the more accurate one, the closest accuracy to 100 goes to the top of the stack. So if you see 14 seconds ago, 10 seconds ago, 6 seconds ago, it's not like in order of job done. No, it's in order of accuracy. We still have, if not this one that says completed would have come down, but it's completed. This training job means the accuracy is really high. That's why it stays at the top. So we have a lot of work. All of this, you can see the type of job. It's a processing job. These are all the pre-processing, feature engineering that's been done. If you want to take a look at them, you could click on it, right click, and open in trial details. If we open in trial details, for instance, that this is we could look at the metric for pre-processing parameters. This is the underlying infrastructure, the size of the volume, the size of the server size, and where the artifacts are stored. For pre-processing, we don't have any charts. We have charts for tuning jobs. And then here we could choose what kind of okay, it's still in progress. So we'll just wait on for the parameters, but you can see the maximum depth, the gamma, alpha, those are all hyperparameters. So those were processing jobs. Now let's look at the training jobs. If you want to just filter, if you want to see just training jobs, you could filter right here. You see, you could just deploy the model, but we'll do that later on. Let's see how we can view. Yeah, so objective metric class with 1 minute aggregation. So you could do this with any data set. This is over time, X is time. On a line graph or histogram. So our models are still running. And then the last thing we're going to do is to see how to deploy a model. Okay, so we're looking at the different models, how to so the different deployments. Right here, we could we could copy we would need the path, and if we go back to our lab, and this is some are still in progress, but we're going to see let's see how to deploy a particular model, one that is completed. This was completed. You give it a name, my new model, and you can see that you have an instance type already associated. We'll save our prediction, put it in that same folder. We'll call it prediction. In that same folder where you have all of your artifacts. And then deploy model, you just click on deploy model, and that's how our models get deployed. It's still in progress. We're not going to be able to wait. The job is still being tuned, and if we check, we're still tuning, and then when we get to completed, before we now do that deployment. But I've showed you how to typically deploy the model. You just right click. You right click on the model, and you deploy. I want to show a model that I had deployed in the past. So we can see, and then I enable when you. This is the model that I just deployed. It will ask you to enable monitoring. I remember we talked about the monitoring dashboard where you could see how your model is performing in real time. So I enable monitoring. Click here, and then it takes you right here. And then it's capturing your data in real time, and then it creates a baseline performance. And then based off a baseline, it now enables continuous monitoring. And then if there's any anomaly, it's detected, and you can see it on your dashboard. So this document is also available for you to see. This is the one that was already completed. Let's look at the performance of this. So the gamma size that was used, lambda, maximum depth, the weight, number of rounds, 28 times. It went 28 times in the trial to be able to get the best mean square error, the best gamma and lambda function. So if we go to metrics, you can see the mean square error, minimum, maximum, and this is the final value that was used. For this model. This is the data pre-processing. This is the size of the disk and the instance where you could find. Okay, we don't have any charts for pre-processing. So we're gonna just, you can see that we still have a few things in process, but because of time, we would have to end our session here. You could always reach out to me on LinkedIn or Instagram, ISSYY.I, or on Twitter, Isi_Idemudia. I'm happy I've spent this has been the best 2 hours of this entire year. Just spending time with you guys. I hope you found this super interesting. The whole idea is to take this forward and just get on it, get different data sets. I'm not sure that this data set was really interactive enough, but it's not about seeing fancy graphs and all of that. It's about getting the concept behind building models and how these parameters are tuned. That you could play around with any data set. So you receive the core foundation of using Autopilot. And my hope and my prayer is that you take this on and take this forward. Having said that, I recently launched my book, and I'd like to share with you guys. Really just encouraging you. Okay, I need to find it. I need to find it somewhere. I don't know if it's here. Okay, here it is. So this is my memoir that I wrote, just encouraging young people to be able to take their career in technology seriously, because this can lead you to places that you never imagined. The fact that you're frustrated about something that you're trying to learn and you don't think you understand it, you're in a good place. Because the joy is not in the destination, the joy is in the journey. So that journey is super important. The challenges that you're facing, just know that what you need to overcome the challenge is the ability to learn and to learn and to learn. I would make this my book in the next 2 weeks. It will launch. It will be on Amazon. Try and make it available to you guys so you can read my story, how I started at UST and where I am now. My hope is that someone gets inspired. It's been an awesome time with you. Enjoy the rest of your current time. Bye-bye.